Can a simple change of course turn a commercial flight into a borderline operation? Just a few hundred kilometers off the usual route, a minimal correction on the map, and suddenly Antarctica is beneath the wings. A territory where what seems routine can turn into a critical situation, almost impossible to manage. This is the question that guides this journey, a mystery that few truly know. Why does it seem that planes are forbidden from flying over the White Continent? At first glance, the explanations seem obvious: the extreme cold, the total absence of cities and runways, even that detail that always draws attention. Antarctica does not officially belong to any country, but behind these ideas lies a much more complex reality. The reason why almost no commercial flight crosses this territory is not an explicit prohibition, but the sum of technical, climatic, legal, and operational limitations that make Antarctica a void on the world aeronautical map. Today, we are going to break down these reasons one by one. We will enter the heart of this technical puzzle and understand what makes this continent a place commercial aviation simply does not approach. And we will do so by dismantling myths, contrasting intuitive beliefs, and revealing data that are rarely explained in detail. But before talking about laws, alternate airports, or geopolitics, there is something that must be faced first. A constant, invisible threat that does not appear on maps and accompanies any aircraft from the very first minute. A factor capable of destabilizing even the most modern airplane. What is this silent enemy that makes Antarctica one of the most hostile skies on the planet? It is neither a theory nor a written rule. It is the Antarctic climate itself. An extreme atmospheric system that minimizes the margin of error. Antarctica is not just a cold continent, it is the most aggressive aerial environment on the planet, a scenario where commercial aviation ceases to operate with guarantees and begins to confront forces it cannot control. To begin with, some of the most intense surface winds ever recorded are generated here, many of which reach altitudes that directly interfere with air traffic. These are katabatic winds, ultra-dense air currents that plunge from the icy plateau, accelerate downhill, and reach brutal speeds. True rivers of freezing air capable of destabilizing an aircraft even tens of kilometers from where they originate. Added to this is another critical risk: ice formation under extreme conditions. In Antarctica, air masses can reach temperatures so low that any moisture present freezes rapidly and adheres to the aircraft's structure. This ice can accumulate on the leading edges of the wings, alter control surfaces, or affect sensitive sensors such as pitot tubes. And when tiny crystals enter the engines, combustion can become unstable, increasing the risk of a sudden loss of thrust. The Antarctic cold also works against the aircraft's own systems. Jet A1 fuel can become too dense, hydraulic components stiffen, batteries lose performance, and certain fuselage materials behave more fragilely at extreme temperatures. All of this forces the aircraft to operate under very narrow limits, narrower than any commercial airline is willing to assume. And if all this were not enough, there is another feared phenomenon: whiteouts, white storms that completely eliminate visibility, erasing the horizon, the ground, and any visual reference. Even if the plane is flying at high altitude guided by instruments, these conditions complicate any descent, approach, or maneuver requiring external references. In themselves, they do not stop the flight because the aircraft can continue moving without seeing the outside. The problem arises when something forces a descent, a deviation, or a search for an alternative. In an environment without nearby airports, a whiteout does not cancel the route, but it does reduce the margin for decision-making to a minimum, precisely when it is needed most. But even if an aircraft managed to withstand this extreme environment, it still would not be safe. Because as it approaches the South Pole, a new phenomenon begins to make itself felt. What happens when navigation instruments start behaving abnormally in polar regions? As a plane approaches the planet's most extreme latitudes, something begins to change almost imperceptibly. Systems that normally provide clear references stop functioning as they would anywhere else in the world. Orientation becomes more complex, routes require different calculations, and the margin of error shrinks. Although modern aviation relies on advanced technology, the polar regions remain one of the most delicate environments for navigation. To understand this, let's start with the basics: Earth's magnetism. Most traditional navigation systems rely in one way or another on magnetic north. But as one approaches either pole, the compass needle stops providing a stable reference. it begins to oscillate, swings abruptly, or loses orientation because the magnetic field lines become nearly vertical, and magnetic references no longer behave as they do elsewhere on the planet. Added to this is another problem. Routes and headings change rapidly because meridians converge toward the pole. Together, these phenomena make navigating solely with magnetic instruments in that region simply unfeasible. However, modern aircraft do not rely solely on the compass. They use inertial systems capable of calculating their position using accelerometers and gyroscopes. These are technologies that can function without external signals, though they carry an inevitable limitation over time. As minutes pass, small deviations accumulate, which, if not corrected with external references such as satellites or other navigation aids, eventually become large-scale errors. In polar regions where precision is critical and margins for error are minimal, this drift can turn into a serious risk. This is where GPS comes into play, which in theory should solve everything. But even GPS faces challenges in polar regions, not because of coverage gaps, but because the geometry of the satellites changes as the aircraft approaches extreme latitudes. Signals arrive at lower angles, some may temporarily lose accuracy, and the system has to work harder to maintain a stable solution. This does not mean the aircraft goes blind, but it does mean it depends on additional redundancies, certified equipment, and specific procedures to operate safely. In addition to external signals, there is another technical challenge related to navigation charts because aeronautical maps use projections that work well over most of the planet but begin to distort as routes approach the polar regions. Thus, a small displacement on a map near the equator may represent only a few kilometers, while the same movement near the pole can translate into enormous distances. For this reason, aircraft need specialized software for polar routes capable of correcting these distortions and plotting reliable trajectories. In these latitudes, even the map itself ceases to be an intuitive reference. All this complexity is regulated under very strict standards, and operating in polar regions requires that the aircraft meet special requirements reminiscent of ETOPS certifications, designed for long flights away from alternate airports, but expanded with rules specific to these latitudes. This involves carrying extra reserve fuel, redundancy in critical systems, additional equipment for the crew, and a flight plan with very clearly defined escape points. The difference is that, while in the Northern Hemisphere there are alternate airports in Canada, Alaska, or Russia, the southern zone is practically empty. And this is where we arrive at the key point. Antarctica does not forgive mistakes. A navigation error elsewhere in the world can be resolved by diverting to a nearby airport. But on the White Continent, a minimal mistake can leave the aircraft without reference points, without the possibility of recalibration, and without the ability to operate within adequate margins. Because even with perfect instruments, flawless navigation, and the best possible crew, one inevitable question remains that no airline can ignore. If something goes wrong in mid-flight, where can a plane divert to in the middle of the most desolate continent on the planet? Everything then revolves around an essential concept in aviation, the alternate airport. Before an aircraft takes off, the flight plan must include at least one airport to which it can divert in case of emergency, adverse weather, or technical failure. It is not a whim or a recommendation. It is one of the pillars of international regulations. No alternate airport, no takeoff. This is true almost everywhere in the world except in Antarctica, where such infrastructure simply does not exist. Many believe that there are runways in Antarctica, and it is true that there are some bases with surfaces where military, logistical, or scientific planes can operate. However, these are not valid alternate airports for commercial aviation. Why? Because they do not meet the basic requirements set by aviation authorities. These are surfaces far from international standards. They lack conventional pavement or certified lighting, have no reliable navigation systems, and do not have prepared emergency services. There are no hangars, stable fuel supply, or de-icing equipment, and most importantly, none of these runways have international certification. Most of these surfaces are blue ice runways. These are extremely compacted ice sheets, formed naturally under pressure over time. At first glance, they may appear solid, but their structural capacity constantly changes depending on temperature, microfractures in the ice, and atmospheric pressure variations. When a large commercial aircraft lands, it exerts enormous stress on the ground. Aircraft such as a Boeing 777 or an Airbus A330 or A350 concentrate tons of weight on a few points of contact. These types of runways can support medium-sized planes or certain specially prepared cargo aircraft, but they are not designed to safely withstand the repeated demands of a passenger aircraft in regular operation. Additionally, scientific bases lack the minimum emergency services required for commercial aviation. They do not have certified fire trucks or medical facilities capable of treating serious patients, nor do they have maintenance workshops, available spare parts, or qualified technical personnel. Even if an aircraft managed to land without incident, it could remain immobilized for days, weeks, or months, as weather conditions can suddenly close the runway. Another fundamental reason is distance, because Antarctica covers around 14 million square kilometers, an area comparable to connecting all of Europe with Australia, and its isolation means that even following its perimeter, a commercial aircraft could be more than 1,000 or 2,000 kilometers from any suitable airport. This reality breaks the safety margins defined by ETOPS operations, which are designed to limit how long a twin-engine aircraft can remain away from a viable alternate. In the Northern Hemisphere, a polar flight always maintains options such as Anchorage, Fairbanks, Keflavik, or airports in Siberia. In the South, the scenario changes completely, leaving only ocean, ice, and uncertified scientific bases. This operational void makes Antarctica, by definition, a zone unusable for commercial aviation. The technology of modern aircraft has advanced tremendously, but international regulations are clear. You cannot fly over an area where there is no safe place to land in the event of an emergency. When that place is absent, the route simply becomes unviable. It doesn't matter how much fuel is carried, how much redundancy the aircraft has, or how experienced the crew is. Without alternates, there is no operation. And then the problem ceases to be technical. Without airports, without local air traffic control, and without minimal infrastructure, the issue reaches another level. Who really decides what can or cannot be done in the Antarctic sky? The answer is as peculiar as it is fascinating. In Antarctica, unlike anywhere else in the world, there is no clear owner of the sky. There is no country exercising full sovereignty, no authority certifying routes, no agency issuing commercial permits. And without that figure, commercial aviation exists in a legal limbo. To understand this legal vacuum, one must first remember that Antarctica is a unique territory on the planet. Although 7 countries claim sectors of the continent, these claims were suspended both in practice and legally after the signing of the Antarctic Treaty in 1959. The agreement prevents any nation from exercising active sovereignty, leaving the territory without full legal control and, by extension, placing its airspace in a similar situation. The continent thus remains in a kind of permanent diplomatic pause. This treaty also establishes a fundamental principle. Antarctica must be used exclusively for peaceful and scientific purposes. It prohibits offensive military activities, weapons testing, mineral resource exploitation, and any action that could harm its ecosystem. Although the text does not explicitly forbid commercial flights, the spirit of the treaty and its environmental protocols create extremely powerful indirect restrictions. Commercial aviation, with its infrastructure, requirements, and risks, fits poorly within this protective framework. This is where what we can call an operational legal vacuum appears. Anywhere else in the world, commercial flights are regulated by national aviation authorities. The FAA in the United States, EASA in Europe, ANAC in Argentina, etc. These entities certify airports, authorize routes, define procedures, and above all, assume responsibility if an accident occurs. In Antarctica, no national authority can assume that role because none has recognized territorial sovereignty, and that means no one is legally empowered to certify an airport, approve a flight plan, or manage a rescue according to international regulations. Additionally, Antarctica presents another complicating factor: responsibility in the event of an emergency. If a commercial aircraft suffered an accident there, which country would respond? Who would coordinate the rescue? Who would compensate the passengers? Under which legal framework? These questions have no clear answers, since the treaty does not specify a commercial air protocol, because it was simply not designed with mass aviation in mind. Most operations in Antarctica are scientific or logistical military flights carried out by countries within their own programs, not under standardized rules for civil flights. To this vacuum, we must add the environmental factor. The Antarctic ecosystem is extremely fragile and protected by specific protocols designed to prevent any type of contamination. An air accident spilling fuel, oil, or fuselage debris could cause enormous and lasting damage in an environment that takes decades to recover. From a legal standpoint, a commercial airline causing an environmental disaster there could face multi-million-dollar liabilities without clarity on which jurisdiction it would fall under. And this, of course, is a risk no company is willing to take. For all these reasons, although there is no written international law stating that commercial flights are prohibited over Antarctica, in practice the result is exactly the same. No one can approve these routes. No one can certify the infrastructure. No one can assume responsibility if something goes wrong. And commercial aviation, which relies on clear rules and well-defined responsibilities, simply cannot operate in a legal vacuum. And yet, even imagining a different scenario, with a clear aviation authority, certified airports, and a solid legal framework, there remains a question that is hard to ignore. Would there really be any reason for commercial aircraft to fly over Antarctica, even if all of this were resolved? Even if Antarctica had fully certified airports, a clear aeronautical authority, and a legal framework capable of managing commercial flights, aviation would still have no practical reason to fly over it. The reason is simple. The planet's geography and the economics of air transport make crossing the White Continent completely unnecessary and, in most cases, counterproductive. Global air traffic is not evenly distributed. Most commercial flights are concentrated in the Northern Hemisphere, where the main passenger corridors between North America, Europe, and Asia are located. The densest intercontinental routes connect cities like New York, London, Paris, Dubai, Singapore, Tokyo, or Los Angeles, and none of these connections need to approach the South Pole because most air activity occurs in the upper half of the planet. That is why airlines design their route maps, optimizing time and distance within regions that already have extensive established infrastructure. To understand why Antarctica makes no sense from a geometric perspective, it is useful to remember how air routes are plotted. Planes follow geodesics, the shortest paths between 2 points on the Earth's surface. These routes may appear curved on a conventional map, but in reality they are optimal trajectories over a sphere. Most geodesics between major cities in the world pass through northern latitudes. The southern hemisphere, on the other hand, has far fewer densely populated cities, drastically reducing the likelihood that an optimal route would cross Antarctica. Even when considering long southern hemisphere routes, the logic remains the same. Flights such as Santiago to Sydney, Johannesburg to Perth, or Buenos Aires to Auckland might seem like natural candidates for a southern polar crossing, but in reality they are not. The optimal route for these connections rarely passes over the White Continent. Trajectories often skirt oceans or travel along more manageable latitudes. Additionally, prevailing winds and weather make crossing extremely cold and remote areas less efficient. Antarctica does not offer shortcuts, only impractical detours. From an economic standpoint, there is also no advantage. Airlines operate to reduce flight time, save fuel, and minimize operational risks. A flight crossing Antarctica would require large fuel reserves, multiple redundancies, special equipment, and additional procedures. All of this costs money, increases the aircraft's weight, and therefore increases consumption. If, after all that investment, the flight is neither shorter nor faster than an alternative route over the ocean, the operation simply does not make sense. Furthermore, airlines design their routes based on real demand. Antarctica has no cities, no permanent civilian population, and no economic centers capable of supporting a direct commercial operation. From a logistical perspective, it is an empty space, and airlines avoid flying over regions that do not provide passengers or strategic value. Today, even in an ideal scenario, flying over the White Continent offers no practical advantages compared to existing routes. All of this leads to a clear conclusion. Antarctica is not a barrier because it is forbidden, but because it offers no operational value to commercial aviation. It does not shorten routes, it does not reduce costs, and it does not connect regions with sustained demand. From a logistical perspective, it is a void that provides no benefit to global air transport. This is true for commercial aviation, but outside that world there are aircraft that do approach the White Continent. Although commercial aviation completely avoids Antarctica, there are operations that, by their nature and purpose, do approach it. These are very specific missions, carried out under criteria completely different from those of a commercial flight. They do not transport passengers en masse, they do not aim to optimize costs, and they do not follow the usual route planning standards. These are highly controlled scientific, logistical, or tourist operations, and each of them confirms, in one way or another, the extreme risk of flying in this environment. One of the most important categories is scientific and logistical flights. Countries with permanent or seasonal bases in Antarctica operate aircraft specially prepared to transport supplies, researchers, and equipment. These missions use planes such as the C-130 Hercules, the Basler BT-67, or the Twin Otter, models capable of taking off and landing on blue ice or compacted snow runways. But beyond the aircraft, the real challenge falls on those on board. Crews are trained in polar survival, extreme weather, and navigation in environments where visual references can disappear suddenly. These flights do not follow commercial rules, but strict internal and military protocols which allow them to operate in conditions no airline could accept. Another category consists of military and logistical support operations. Although the Antarctic Treaty prohibits offensive military activities, it allows the use of military resources for scientific, humanitarian, and support tasks. This means that air forces from several countries carry out regular missions to supply bases, evacuate personnel, or deliver critical equipment. These flights can operate in conditions that the civil environment would never authorize, with limited infrastructure, restricted communications, and very narrow weather windows. The tactical flexibility of these aircraft and their crews makes missions possible that would be unthinkable for commercial aviation. And it is precisely this difference that draws the true line between what can be done in Antarctica and what will never form part of commercial aviation. Throughout this journey, we have dismantled an idea that seemed simple: why planes are forbidden from flying over Antarctica. And what we discovered was not a single reason, but a full network of factors that combined make the White Continent incompatible with modern commercial aviation, a space where technology, regulations, and nature itself meet their most demanding limits. On one hand, Antarctic weather represents an extreme challenge: unpredictable katabatic winds, aggressive ice formation, and temperatures that compromise essential systems. Added to this is the complexity of polar navigation, where magnetic distortion, inertial system drift, and limited satellite coverage make orientation an exercise in constant precision. And on the ground, the situation is no better. There are no alternate airports, no certified infrastructure, and no way to operate under the safety standards that civil aviation requires. From a practical and economic standpoint, the White Continent also offers no faster routes or operational advantages because there is nothing to be gained by passing over it. That is why, more than a forbidden space, Antarctica ends up being a sky where commercial aviation simply cannot operate. Its extreme isolation, the hostility of the environment, and the fragility of the ecosystem combine to create a scenario in which every factor, from the weather to the legal framework, pushes in the same direction. If this journey has helped you see aviation with new eyes, here you will find more stories where we dismantle ideas that seem simple and take them to their core. Subscribe and explore the channel because each video is part of the same investigation into how machines, technology, and the limits of the world we fly in really work.